Hello guys, how's it going? I'm just gonna check that everything's alright with the systems and that everything is live. Let's check the screen and the audio is good. It's perfect. So awesome. So now we are in this fifth course. This is developing AI systems with OpenAI. And so far what we have learned is basically how to format the response not only in text but in, for example, JSON, how to handle exceptions, using rate limiting, how to do batching, and how to put limits to the tokens. How to limit the number of tokens that we're passing. I think one of the most interesting was the batching part. I didn't know that you can send like consecutive users messages, and also the rest right is new. I haven't done this in Python yet. It's quite nice. Anyway, let's continue. Let's go to the developing AI systems with OpenAI. This is the chapter 2. So let's go.
Welcome back. In this video, we will introduce OpenAI's function calling feature, exploring some concepts before moving to its applications in the next video. OpenAI endpoints support tools that can be defined to have the models return more specific information or return more precise outputs by defining a certain structure. Tools are options given to the endpoints to enhance the capabilities of the API call. Let's consider an example where we wanted to use the OpenAI API to control a smart home device, such as a smart light bulb. We could create a function that takes a natural language command, sends it to the OpenAI API for processing, and then interprets the response to control the hardware accordingly. The response should be interpreted consistently across different users, so we'd have to make a change to the original API call. This is where tools come in. By defining certain rules, we set the model output to follow a precise structure. To specify this type of behavior, we'd have to define our tool as a function that outputs the expected response, hence the name function calling. So far, the way we generated structured outputs has been to have the API generate JSON outputs by specifying the response type and passing a system message, such as in this example, where we're asking to output scientific names of trees in JSON format. Up to this point, however, the reliability of our outputs has remained limited, as the JSON keys created when calling the endpoint this way are purely based on the model's interpretation, which can sometimes be inconsistent, such as in this example, where different dictionaries containing names of trees have been generated using the same endpoint and prompt. Function calling addresses this issue by enabling OpenAI models to take user-defined functions as input, resulting in consistent responses without the need for complex text processing techniques. By ensuring a reliable structure of our API response,
Wait.
asking to output
So in function calling, what we do is
scientific names of trees in JSON format. Up to this point, however, the reliability of our outputs has remained limited, as the JSON keys created when calling the endpoint this way are purely based on the model's interpretation, which can sometimes be inconsistent, such as in this example, where different dictionaries and prompts to take user-defined functions as input, resulting in consistent responses without the need for complex text processing techniques. By ensuring a reliable structure of our API response, we can integrate our AI application with external
this is the thing that I mentioned you, that it's generating like a JSON object, but it can be any. It can be this, it can be this, you don't know, you know? But in this case,
structure of our API response, we can integrate our AI application with external systems and be more certain of its reliability. For instance, we can extract instructions from our natural language input and pass them to a smart home system. We can call multiple functions to provide complex responses, formulated by means of different functions. For example, in an e-commerce customer service chatbot, where the prompt given as input could trigger different functions, such as a function that retrieves the product catalog, one that reads from the website's FAQs, or another that provides a response. Finally, we can use function calling to define functions that enhance the responses by calling external APIs, such as, for a weather chatbot, calling an API to return current temperatures at specific locations. We are now ready to deep dive into integrating function calling in our API calls. But before, let's review some concepts through the next exercises.
All right, this is something that I've seen in Node. I've done an integration of OpenAI with Node.js, and now I'm gonna move like a lot of the services that I have to Python. So, okay, let's run into that. I'll explain you later about that. Function calling allow assistants to interact programmatically with other functions or applications. Yes. Can directly control additional integration? No. Without oversight or permission? No. Integrating external APIs such as weather chatbot, calling an API to return the current temperatures. Yes, that's correct. So these two. So function calling steps enable the use of custom functions as input to the OpenAI endpoint. So we're gonna send custom functions to the OpenAI endpoint, resulting in pre-consistent the responses. Scale process using OpenAI endpoint with function calling. So the user inputs a prompt. The model interprets the prompt based on the definition function. So I'm going to put the prompt with the functions. If the external functions are called, the data structure from the prompt are used to trigger the functions, and the response is returned. Yep.
Now that we are familiar with function calling, we'll take a look at how it can be utilized in practice. In this video, we'll dive into using function calling to extract structured data from unstructured text. Let's say we wanted to extract specific parameters from this job description for a data scientist role. Instead of passing a prompt asking to return a JSON and a response type as in previous cases, we add a new function definition to request the specified output. This is done through the tools parameter that we add to the chat completions endpoint. When defining a function to be passed to the tools argument, the format is a list of dictionaries. Let's take a look at how to build one. First, we specify the type of tool as function. The function type is used when we want to call our own user-defined function. We then move to specifying information about the function itself. Under the function key, we specify a name for the function, a description of what the function should do, and its parameters. In this case, we provide a name for our function related to extracting job information, a short description stating that the function gets information from text, and parameters. Let's now take a look at setting the parameters within the function. In the parameters dictionary, each key is the key that will be included in the resulting JSON schema. Each value is a dictionary containing the type of data it will hold and a description to help the model extract it. In this example, the keys are job and location. They are both strings, and we provided short descriptions to state that they refer to the job title and office location. Finally, let's take a look at the response from our API request that uses function calling. One thing that changes from previous calls is that when using function calling, the response will be nested in two calls, function arguments. Notice that two calls is a list, as there is an option to call multiple functions, and in that case, each item in two calls will contain the response from each function. In the example we have, the job and location extracted from the job advert are the outputs.
So if I pass this function, then this is gonna describe what is the response of the function. So when I receive the answer, I can, instead of getting the message content, I can see if any of the tool calls were called. In this case will be the, because this is an array, will be the 0, and it will be function and the arguments, and I'll have the response of the arguments, which are this one's job and location. This is more or less what I understand.
Calls, function, arguments. Notice that two calls is a list, as there is an option to call multiple functions, and in that case, each item in two calls will contain the response from each function. In the example we have, the job and location extracted from the job advert are the outputs. As we wrap up our video, we've seen how function calling can be helpful to transform raw information into precise data, paving the way for more automation in our applications. Continue to unlock the full potential of the OpenAI API with the next exercises.
Nice. Let's continue. Okay, now I'm gonna create a new file here. It's gonna be number 6, and it's gonna tools parameter 6 tools parameter. And in here, you're developing an AI application for real estate agency and have been asked to start some key data from listing: house type, location, price, number of bedrooms. You check completions input with function call to sort information. The message listing contain real estate listing and function definition contain the function call defined as a tool to be passed to the model that has been preloaded. All right, so in the messages, I should put the preloaded message listing, and add your function definition will be in tools, in will be equals to function definition, and I'll have in the response that this will be response that choices the 0 and then tools and then 0 and then take a hint. Let's tool calls. Okay, but then tool calls function arguments. All right, so but because here it was already predefined. Okay, so I'm gonna copy this here, and I'm gonna ask Cloud to expand this so we can go deeper into detail. From here, response client. So I'm gonna ask cooperative path. Let's clear this conversation. Clear. Let's for this file. Can you create a message listing and function definition so we can run the script? And I'm just asking Cloud to create this function and this function that technically here is defined, but in my local is not defined, and I would like it to be defined because I want to run it locally too. Let's wait. I mean, of course, if I run the solution, it'll work. But I want to go more into depth, like in how because here from the message, I assume that the message contains like the parameters like home type, single family, something like this. But and all of these fields, but I would like to wait, just in case one of the outputs should like this, so it can reverse engineer and generate something that generates me this. So it's not too big then. I just hope I don't create the. Okay. No, I'll run it. So the message is extract the real estate listing information from the provided system, and the role is the listing description. In this description, it says like Charming single family for sale in Springfield. Springfield, okay. From the Simpsons, 2 bedrooms, a spacious backyard under the kitchen. So the function definition. So the system detects that we can call this function is like extract listing info. Then the parameters, which is the this defines that I'm gonna return an object if I call this function, and in the object the properties are home type, the location, which in this case I return the bedrooms, and the font type location price bedrooms. And I'm gonna ask her, can you explain me better how does the structure of function definition works? Okay, so it says, you define a list of tools. Is the kind of tool the function itself. It's the multiple tools, so even if you just define one goes inside of an array, you could use a second array of this. Okay. Array tool declare what kind. So the function is the main type, but it exists. The field exists, so OpenAI can support other tool kinds without changing the structure. Okay. Tricky is to a demo for a model to read, not for code. So name is the identifier of the function, and the description is it tells like still textually when and why to use this function. Okay, so if the model decides that we should use this description, I should state clearly what this function does. Community prompt. It tells the model when and why to use this function. Okay. The shape of the arguments the model must produce. Okay, this is the thing that I told you. The shape of the arguments, the parameters is a JSON schema. It's an object. Yeah, the properties. Okay, each entry properties one argument. Okay. Okay, that's awesome. So we got this, and let's run it. There will be the number 6, Python 6. And what do we have here? This is the second exercise. Okay, this is building a function dictionary. You're working on a research project where you need to extract key information from a collection set of scientific research papers. The goal is to create a summary of key information from the papers you are given. That includes the title and the year of the publication. To compile this, you decide to use the OpenAI API function with function called to extract key information. So the get response function and messages. The function definition variable has also partially been filled already. Parameters type. And this is like an object. So the parameters type should be an object. So that's clear. And about the parameters, so the parameters type is an object, and the property should be an object that gives me, it's a dictionary, title It's one thing, and then the other thing is that I should get is the year. Wait. Yeah, year of publication. And then in here, each one is an object, and then we should define inside the type, and also here the type. I assume that both are string, and that this description and also description here, and the description here for the title should be title of the publication, and here it should be year of publication. And with the get response, I got this, and this. Find the properties for writing the year of publication for research papers. Okay, so if I run the code, it should work good. The name response is not defined, but it's here. Okay, I am pretty sure that this is environment error, so I'm gonna reload the page and I'm gonna run it again. Okay, let's see. Yes, it worked. It worked good. So I'm gonna 7 boolean function dictionary. And then from here I need to do this. I need to do this. Then I need to copy relative path, and now for this file I'm gonna leave it as a context because I did something similar. Can you please generate the get response and the function definition so I can run the script. So I'm asking Cloud to generate this function definition and also to generate the get response function, so I don't need to code it by my own. So if I submit this, I get an error. I see, so I just need to call it year. Okay. Nope. I'm gonna run it. So the get response, pass the function definitions and the messages in the tools. You get response arguments. So getting the response from the arguments. Here's the abstract. And I call it, and things work good, and then I do Python. This is 7. And I'm gonna continue. Nice, very nice. It worked. Now extracting the response. You work for this. We're gonna create a new file, which is gonna be 8. Extracting response. Okay. Okay. You work for a company that has just launched a new smartphone. The marketing team has collected customer reviews from various online platforms and want to analyze the feedback to understand the customer sentiment and the most talked about features on the smartphone. To accelerate this, you use to open it to track the structured data from these reviews using function calling. You now need to write a function to clean the output and return a dictionary of the response from the function only. The correct function message variable contains and function definition features from reviews have been preloaded. Notice what messages from this feature can be passed as arguments to get response. So so we already have the definition, but I want the data cleaned, so I need to use function calling. So struct dictionary should be, so this is defined. I'm getting this and getting this. So here I'm gonna pass the answer, so it should be here. So I should pass the response, and then in the response so I should print the struct dictionary response. So here I'm getting all of the dictionaries that I mean the structure response that we require. So I'm gonna do the same here, and I'm going to response, get response, message, function definition, instruction error, print this scenario. Okay, and now can you please find get response on the messages and function definition in this file. This is the problem, and it will generate like that all of the missing elements that I need there. This should be alright already. Yep, that's good. And now we're gonna be working with multiple functions. Just give me 1 second because I need to. How long are we streaming? 20 minutes. Working with multiple functions. Okay, this is gonna get more interesting. So here in data we have the review. In this case we had just one review, and wait, I'm gonna come back one previous because I need to make sure that I need to do this, and I just want to add here that consider the outputs to be because I want the script to return that type of output. So my functions should return these fields and parameters. So here I'm passing oh, so this is only about one product. Okay, it makes sense. That's why it's just returning one. And then if I run, I'll just get that. That's cool. And yeah, I got this. It's nice. Now let's do the
Now
same but with multiple functions.
Use function calling to extract structured data, we're ready to add a new functionality to our API call, passing multiple functions to be used in the response. The ability of the model to handle multiple functions is called parallel function calling. Parallel function calling enables an improved communication with the model, enhancing its ability to process and generate responses. Let's go back to the previous example where we wanted to extract job information from job descriptions and assume we'd like to concatenate an additional function to the first one. In the function definition, we'll keep the previous function to extract the job data. But this time, let's say we'd also like to know the time zone that corresponds to the location in the job advert to check the feasibility of working remotely. We set up this function in the same way as for the first one and add it to the list using append. And finally, as we did before, we trigger function calling by passing our function definition to tools. In the case of calling multiple functions, we'll have to use indexing to select the different responses from the tool calls list, as shown. We might end up with a
this is something I don't like because we should be getting that by the function name, not by the index of the array, but okay.
long list of functions in our tools. And in that case, the default behavior of the model is to choose which one to use based on the message and function definitions. This is the equivalent of setting tool choice as auto. If we want the model to pick a specific function from our list, we'll have to modify tool choice from auto to a dictionary containing the name of the function we'd like the model to use. When setting specific functions, the model can make assumptions about values to assign, even if they're not present in the message. To avoid this behavior, a good strategy present in the message. To avoid this behavior, a good strategy is to use the system message to communicate this to the model. Before specifying the user message, for example, we could write a couple of system messages asking not to make any assumptions and to ask for clarification if needed, such as the ones shown. One thing to account for in this case is that the model might return an empty dictionary if it cannot find anything suitable to respond to the prompt. Let's test the behavior of the model by asking for a piece of information that is not in the job description provided, the starting salary for the role. And that wraps up our video on function calling with parallel functions. You can continue with some exercises to incorporate parallel function calls into your projects. Let's practice.
It's awesome. So guys, let's take a break. I'm gonna go take a shower, walk my dog, and then let's come back with our third streaming of today. So